Alright, this lecture deals with the sum and difference formula of trigonometry. And the way it works is if I have two angles that are being added together, say sine of x plus or minus y, or two angles that are being subtracted from each other, it would equal sine of the x angle times cosine of the y angle plus or minus cosine of x sine of y. So if I expand this for you, if I was to say sine of, say, x plus y, this would be equal to sine of x cosine of y plus only cosine of x sine of y. Now, likewise, if I did the subtraction, it would just be the negative version of the formula. So we're actually dealing in four different formulas here. Of course, this would be sine x cosine y minus cosine of x sine y. Now, the only thing that I really need you to pay attention to is the fact that cosine is reversed. And that is, if I have cosine of x plus y, it's cosine of x cosine of y minus sine of x sine of y, and then cosine of x minus y would be the same thing except positive. All right, so those are the things that I really need you to pay attention to as far as this lecture goes. Now, I'm going to go ahead and delete that. We're going to use this top left box here as our reference box, but after doing a few of these problems, you get the hang of the pattern of sum and difference formula. Now, the way this is actually used is sum and difference formula is used to figure out the measures of angles that we don't readily know. So let's go ahead and just make a list of angles that we do know. So some known angles here. Well, what do we know? Well, we know all the angles that are defined on the unit circle. If I was to convert these to, or let's do the radians first. I mean, I know what 0 is. I know what pi over 6 is. I know what pi over 4 is. You know, pi over 3, pi over 2, and I could keep going on. I could, include 3 pi over 4, 5 pi over 6, pi, let's see, 7 pi over 4, 11 pi over 6, and all the ones in between, right? 2 pi. I know all of the ones in between there. So let's do some degrees that we do know. I mean, I know we've worked mostly in radians, but we should know the degrees as well. If I said 0, I know 30 degrees. I know, oops, not 36. I know 60 degrees. I know 90 degrees. There's, whoops, and who could forget 45? And I know a few more. There's like 120, 180, 225, 270, 360, and all the ones in between that. So basically, we're going to use sum and difference formula to convert things into degrees or radians that we already know in order to figure out what the measure of that particular angle is. So if I was to give you an example, like number 1, we have never dealt with sine of 105 degrees. Okay? Now, it's just as easy to put in your calculator, but if I asked you to find the exact value of sine of 105 degrees, what we're going to do is we're going to change this into something that we already know. Now, there's an infinite number of combinations I can use using some degrees here in converting into sine of 105, but let's do something that is pretty readily available. I could say that sine of 105 degrees is the same thing as saying sine of 60 degrees plus 45 degrees, right? Because I know sine of 60 and I know sine of 45 individually, and if I add them together, they still equal 105. So from here, I'm going to go ahead and use this sum and difference formula. If I reference it right up here, sine of x plus y is equal to sine of x cosine of y. So this would be the x term, this would be the y term. So sine of 60 times cosine of 45 plus cosine, not that it matters, cosine of 60, and then sine of 45. Now from here, I can go ahead and readily convert these. Sine of 60 degrees is going to be rad 3 over 2. times rad 2 over 2. Cosine of 60 degrees is going to be 1/2. And then sine of 45 degrees is going to be rad 2 over 2. So let's go ahead and do this calculation here. Rad 3 times rad 2 is rad 6 over 4, plus this is going to be rad 2 over 4. Now, when I combine these two, I get rad 6 plus rad 2, and since I already have a common denominator, it's going to be all over 4. And there you have it. That is how you do sum and difference formula. Let's do a few more. Alright, if we look at sine of 285 degrees, again, we got to break this up to make it into some angles that we already know. So I'm going to go ahead and make this sine of, say, 225 plus 60. Right? In case you guys don't know, 225 is the 45-degree angle in quadrant 3. And then we should know sine of 60 degrees. So this is going to be sine of 225 cosine of 60 plus cosine of 225 sine of 60. Well, this is going to be negative rad 2 over 2. Cosine of 60 is going to be 1/2 plus this is also going to be negative rad 2 over 2, cosine of 225 degrees. And then sine of 60 degrees is going to be rad 3 over 2. Alright, looks like we've got negative rad 2 over 4 minus, right, because a negative times a positive, negative root 6 over 4, so we can go ahead and simplify this into negative rad 2 minus rad 6 all over the common denominator 4. Alright, let's do one last one, which is cosine of 165 degrees. So let's go ahead and break this up. And sometimes I feel like the hardest part is knowing what to break these up into. I'm going to choose 120 plus 45, right? Because those add up to 165, and now I can use my cosine sum and difference formula. Now I got to be more careful with cosine. Cosine is opposite our intuition, so it's going to be cosine of 120 cosine of 45 minus, right, because cosine's opposite, sine 120 times sine of 45. Now, cosine of 120 degrees, that, in case you guys don't know, is right here on the unit circle, right? And so that is going to be negative 1/2 times root 2 over 2 minus sine of 120 is going to be root 2 over 2. Oh, sorry, getting ahead of myself there. Sine of 120 is going to be root 3 over 2, and then times root 2 over 2. So what you get is negative root 2 over 4 minus root 6 over 4. Kind of the same answer there. That's kind of neat. Negative root 2 minus root 6 all over 4. Kind of cool. All right, let's get started with the second part of the lesson. Hang on. In number 4, they give you something kind of odd. They give you something that looks really complicated and some numbers that you probably don't know readily have angles known for. But what you can do from here is you can actually work backwards. What you can identify is that this is already a group of angles that have been sum and difference formulaed out. So this cosine, cosine plus sine, sine, it reminds me somewhat of cosine of x, cosine of y, plus sine of x, sine of y, right? Because notice how the 80s are the same and the 20s are the same. So from here we can go ahead and just work backwards. We can identify x as being 80, right? Because that's the thing that's coming up first. Y is 20. And since it's being added together here, we can go ahead and convert backwards into cosine sum and difference angle of 80 and 20, some kind of interaction between them. Now remember, with cosine, the symbol is different, or it's opposite on the insides of the parentheses, so it's going to be 80 minus 20, which means this is cosine of 60 degrees, and we readily know what cosine of 60 degrees is. That's 1/2. So with these types of problems, you definitely want to work backwards on. All right, so let's take a look at something else. A sine of 60, sine of 15. Whoops, not sine, cosine. minus. So because I have an alternating sine, cosine, cosine, sine, this leads me to believe that this is some sort of sum and difference of sine. Now because it's negative and sine goes with our intuition, we can do that, and it's just 60 minus 15. That is sine of 45 degrees. That is rad 2 over 2. Okay, that's about it for sum and difference formula. We'll see you next time.